In this example, we're going to give a rough sketch of the function f of x is equal to sine of 2x. And we note here that what the 2x is going to do is it's going to affect all of our x values by dividing them in half. So I've listed the 5 points that we should know from sine of x, and we're going to go through them one by one and divide the x values in half. Our first point, which is 0, 0, is not going to be affected because x is equal to 0 in this case, and if we divide that in half, it's not going to change. Our second point on sine of x is pi by 2 and 1. And if we divide pi by 2 in half, we get pi by 4. So we'll have a new point, pi by 4 or 1. Our next point is pi 0. And if we divide the x value in half, we'll get pi by 2 and 0. Our next point is 3 pi by 2 negative 1. This is going to go to 3 pi by 4, negative 1. And then our final point, 2 pi 0, will be moved to pi and 0. So let's go ahead and plot those 5 points, starting at 0, 0. And then our next point was pi by 4 and 1, which is here. The next point after that was pi by 2 and 0, which is here. And then we had 3 pi by 4 negative 1, which is down here. And then finally pi and 0, which is this point here. And if we connect these with a nice, smooth, sine-like curve, we should get something like this. So maybe you're able to see here that actually 2 copies of sine 2x are going to fit in the interval 0 to 2 pi. This 2 here actually halves the period of our function. So our typical sine function has a period of 2 pi, but sine of 2x is going to have a period of 1 pi. Let's take a look at one more example of a sketch of a sine function. Here we'll look at f of theta is 2 plus 2 sine theta. So in the first column over here, I've given out our 5 points of our usual sine function. And what we want to do is move from our first column to our second column, which is the function 2 sine theta. So remember that this 2 here has the effect of stretching our sine function in the y direction by a factor of 2. In order to accomplish this, we can multiply all of our y values by 2. This is going to give us the following 5 points: 0, 0, pi by 2 and 2, pi and 0, 3 pi by 2, negative 2, and 2 pi and 0. Finally, our last step will be to move from column 2 to column 3. And the difference between these two functions is the addition of the number 2. So this second number 2 here has the effect of shifting our function up 2 units in the y direction. In other words, we're going to add 2 to all of our y values to get our final column. And that's going to give us the following 5 points: 0, 2, pi by 2, 4, pi and 2, 3 pi by 2 and 0, and 2 pi and 2. So let's go ahead and plot these 5 points that we've come up with to get a rough sketch of our function. So once again, here's a rough sketch of our typical sine function with our 5 standard points. We're going to go ahead and plot those other 5 points, our first one being at 0, 2, which is here. Our second one is at pi by 2 and 4, which is up here. Our third one is at pi 2, which is roughly here. Then we have 3 pi by 2 and 0. And finally 2 pi and 2, which is roughly here. Then we want to connect them with a nice smooth curve like this. And we'll label that as 2 plus 2 sine theta.